This is seriously like the strongest Lego launcher ever. If you're just here to copy the design, then boom, there you go. It's a 40:8 gear ratio followed up by 24:8. But if you don't have the exact parts, or just want to know more about how string launchers work in general, then let me introduce you to the science behind it, so you can create your own custom designs. Most people's first string launcher starts out something like this, a simple string connected to an axle that turns the bay. While it does work when constructed properly, it's rather weak compared to other launchers. To make it more powerful, you'll have to introduce the idea of gear multipliers. You can increase the speed of the spin by a ton, depending on the ratio of teeth used on each gear. However, by increasing the final speed of your launcher, it'll also take that same amount, much more power to spin it as well. By the time you reach a gear ratio of 4:1, you'll find that you can't pull the string anymore. What happened? Well, now it's time to talk about torque, a linear force that twists an object around a specific axis. In a string launcher, this refers to the force of the string that turns the wheel, which will eventually turn the bay. To maximize the effectiveness of a launch, we must maximize torque. Torque equals force times radius times the sine of theta. Force is how hard you pull the string, which is the launching part of the launcher. Radius is the radius of the wheel, meaning that a larger one will have more power, but as a drawback, requires more string to complete one rotation. Finally, theta is the angle formed between the string and the line from the axis to the part where the wheel and string touch. Sine of theta is the greatest when theta equals 90 degrees, meaning the string should be about perpendicular to the axle. To summarize, you'll need a larger wheel and a perpendicular launch to maximize the power needed to launch your gear multiplier launcher. After a couple days starting from scratch, I made this beauty. It has a gear multiplier of 15 and has enough string for 14 full rotations. If you can pull the entire string in 1.5 seconds, which isn't even that fast, you could reach speeds of up to 8,400 rotations per minute. Now that you have the tools to make your own Lego launcher, go try to create one or improve a previous design. If you have any questions, feel free to leave them down in the comments below. A like and or subscribe would be greatly appreciated. Until then, Lego Bays,